Okay, we're going to talk about solving equations with absolute value and inequalities. This is not difficult. Kids kind of do mess it up at times, but hopefully, since it's going to be close to when you take the test, it'll be fresh in your mind and you'll do pretty good at this. So let me load this up here. Okay. Okay, so first of all, absolute value. What happens is this, kids get confused. Your teacher somewhere along the line tell you that for absolute value, they're like, ooh, make it positive. But that's not good. We don't want to think of it that way. Okay. We don't want to think about make it positive. What we want to know is that absolute value means distance from zero. Okay. If you think of it as distance from zero, these problems are a lot better because we're going to use this example. Let's say I say the absolute value of x is 5. What this says is there is a number that is 5 away from 0. Well, there's two numbers that are 5 away from 0. Inside of here, that could be 5 or it could be negative 5. The absolute value of 5 is 5 and the absolute value of negative 5 is 5 because there are two things that are 5 away from 0. There's 5 and negative 5. So these are going to have two answers. I used to tell kids if there's two bars, there's going to be two answers. And it's not always plus or minus, and kids get that confused too. What you're going to do is you're going to cover up what's inside the bars, and you're going to make the statement true, and then you're going to solve it from there. So let's see if we can look at a couple examples. That's the one I just talked about. So 5 is 5 away from 0 and negative 5 because you can go to the right or to the left. But let's say that instead of saying the absolute value of x was 5, let's say I said the absolute value of x plus 1 is 5. Well, this is not much different because inside of this absolute value symbol, there are two things that could make it true. Like cover up the x plus 1, pretend that's not there. What could be inside the brackets that make that true? Well, the absolute value of 5 is 5 and the absolute value of negative 5 is 5. So what this means for us is that x plus 1 could equal 5 or x plus 1 could equal negative 5 and it will work out. So when you solve these, you get x equals 4 as one of the answers, and you get negative 6 as the other answer. And some kids get confused. They're like, no, it can't be negative. Well, it's not negative, guys. If you plug in the negative 6 into the equation, negative 6 plus 1 is negative 5. The absolute value of negative 5 is positive 5. So that's what you're going to do. You're going to figure out, you're going to get the absolute value all by itself, figure out what values make it true, and then solve them separately. So look at this guy. First thing I need to do is I got to get the absolute value all by itself. So I'm going to add 1. So the absolute value of x minus 3 equals 5. So this is kind of what we were talking about a minute ago. What could be in there to make that true? Well, this guy could be 5 and it will make it true, or it could be negative 5. So we just solve it out. X minus 3 equals 5, or x minus 3 equals negative 5. Add 3 to both sides, and x equals 8 is one of the solutions. Add 3 to both sides on this one, and x equals negative 2 is one of the solutions. You can plug it in if you want. 8 minus 3 is 5. The absolute value of 5 is 5. 5 minus 1 is 4. Same thing with negative 2. The absolute value of negative 2 minus 3 is the absolute value of negative 5, which is 5. 5 minus 1 is 4. So what about if you have inequalities? Okay, well, inequalities, when you have absolute value, you're going to get two different possible cases. You're going to get either an and statement or an or statement. Okay, and how can you figure this out? Well, you need to remember this. Less than is an and. Less than and then you need to remember great or than. So when you say great or than, if it's a greater than sign, it gets the or. See, because what happens is with absolute value is you can't have something that is, for example, this is what an or looks like. You can't have something that's bigger than 2 and less than -2. It has to be one or the others. So when you have OR graphs, the graphs end up looking like this. OR graphs to me look like oars of a boat. If you were riding in a boat, a boat, there's your boat. These are like the oars. So if you have a less than, you're going to get an and, which looks like we talked about a sandwich. That could be, you could be bigger than -2 and less than 2, and that would look like a sandwich or a bar. But if it's an or, it has to be on the outsides like the oars of a boat. So you still have to break it into 2 equations, and you pretend it's an equal sign, and you fix it up after the fact. So let me show you what I'm talking about. So here, it says the absolute value of x is less than 3. So I see the less than sign. I don't want to underline it. That's dangerous. And I know that it's going to be an and, because less than and. So what are the 2 things that could make this true? Well, it could be 3, or it could be -3. Those are going to be my boundaries, 3 and -3. So x could equal 3, or x could equal -3. Those are the boundaries. So the small numbers on the left and the big numbers on the right. They're open circles because it's a less than sign and looks like a sandwich. So that means my answer looks like this. If you write it in the correct notation, you put parenthesis because it's an open circle, -3 to 3, finish up the parenthesis. What if it was the next one? What if it is the absolute value of y is greater than or equal to 1? Well, this is a great or than sign, so that's going to be an or, and it's an equal, so it'll be solid. What could be in here that makes it true? Well, y could equal 1, or it could equal -1. So you put the small number on the left and the big number on the right. This time it's a solid dot, and it's an OR graph. So the OR graphs go on the outskirts like oars of a boat. And then when you write what the equation means, you start with the small number. So it's -infinity to -1. That gets a square bracket. Put a U in there, which kind of looks like the boat. Then start at 1 and go to infinity. What happens when there's variables involved? So what about this last guy? Well, first of all, it's a less than sign. So this is an and. And now we'll just use our boundaries like before. This is a 4. So what could be in here to make it equal? Well, it could be 4, or it could be -4. So you just solve it up. 2x plus 3 equals 4. 2x plus 3 could equal -4. So solve it up. -3 minus 3. 2x equals 1, and x equals 1/2. Solve this one up by subtracting 3, subtracting 3. 2x is -7, divide by 2, and it's -7/2. Put the small number on the left and the big number on the right. So -7/2 and 1/2. Solid circle because there's an equal to sign, and this time it's an and again, so it gets a square bracket. Make your equation, square bracket, small number to big number, close it up, and that's all you have to do. So what you're looking for here is the type of equation, and then you will probably graph it before you write the answer. So this is a less than, it's an and, it's going to be open circle because there's not equal. Pretend it's an equal sign, and that would be a 5 and a -5. So my 2 equations are 3x plus 2 equals 5, 3x plus 2 equals -5, and that will give me my boundaries. Subtract 2, 3x equals 3, and x equals 1 as one of the boundaries. Subtract 2 from the other one, I get 3x is -7, divide by 3, and x equals -7/3 for the other. Small number on the left, big number on the right. So -7/3 and 1. Open circles because it's not equal to, and goes in the middle. So you just write what your answer is. It's a parenthesis because it's not a square bracket, small number, to the big number, also a parenthesis. How about this one? This time it's a greater than, so great or than, and it's going to be a solid circle because of the equal. What could be inside this to make it true? Well, it could be 1, or it could be -1. So those will be my boundaries. 5 minus 2x equals 1. 5 minus 2x equals -1. And solve from there. -5 minus 5. -2x is -4. And x equals 2. Use the other point. -2x is -6. Divide by -2. And x equals 3 as the bigger one. So it's always small number and big number. So 2 and 3. Solid dots. This time the graph is an or, which means it goes on the outsides. So we write our response, -infinity to 2. It gets the square bracket because it can equal to it. Put the boat in, and 3 to infinity. I think that's it. This should be a pretty easy lesson compared to the last one, so you should have time for homework questions.